Alrighty, let's start the last lesson in Unit 7, and this is a lesson on factoring completely. So let's first review the first type of factoring that we found. We learned how to find a GCF, the greatest common factor, and how to divide it out of the polynomial to create factored form. So, if I look at 3 and 6, the smallest number is 3, and I think, can I divide 3 by both of these numbers? I can. They're not both negative, so I won't worry about a negative. And then they both have an x, but the smallest x they have is there's an x2 and an x1, so the smallest one is the x1. So my GCF here is 3x, and now I'm going to do the division. 3 divided by 3 is 1, then x2 divided by x1 leaves me with x with 1, because 2 minus 1 is 1. Then minus 6 divided by 3 is 2, and if I have an x and I take away an x, they go away. And most of the time, if this was multiple choice, how you would see it written is the GCF 3x, and they probably wouldn't write those 1, so they would just write x minus 2. And this is our final answer. If you wanted to practice, you could try multiplying it back, and you would see that you would end up at the original problem. All right, let's look at the next one. The smallest number I see is 3. Luckily, I could divide 3 by all of these terms. Then all of them have the x. And x to the fourth, x to the third, x squared. So the smallest one is x squared. Then all of them have a y. Y to the third, y to the first, y squared. So the smallest one is y to the first. All right, let's write that down. 3x squared, y to the first. And let's see what we get from dividing. 3 divided by 3 is 1. You could write the 1, you don't have to. Then x4 divided by x2, we subtract the x1. It's 4 minus 2 is 2. So x squared. Then y3, take away one of the y's, we would have y2. Then 12 divided by 3 is 4. x3 divided by x2, 3 minus 2 is 1, 1x. And then if we have 1y and we take away the 1y, we have nothing left. And then negative 18 divided by 3 is negative 6. x2 divided by x2 would leave us with no x's, because 2 minus 2 is 0. And then y2 divided by y1, subtract. 2 minus 1 is 1. And this is our final answer. Again, if you tried multiplying this by this, by this, by this, you would end up with the original problem. So that is reviewing how to take out a GCF. Every single problem, no matter what method of factoring we are going to do, we want to try to take out the GCF. So today, we are going to learn how to factor, not only trinomials, but anything, polynomials in general, polynomials completely, by using factoring strategies that we have learned. Alrighty, so let's review how to factor trinomials. This is what we learned in the lesson yesterday. First thing that we are going to do is see if there's any number we could take out. Because the lowest number is 1, there's no point in dividing by 1. It wouldn't change anything. And all of them don't have an x, so we can't really do anything. Okay. Now, because it is 3 terms, that means I'm doing the method where I'm going to find what adds to the middle number and what multiplies to the last number. So I have to find, you don't have to do this part on the side, but I'm going to have to find what 2 numbers add to 2, but those same 2 numbers also have to multiply to negative 15. How I do this is I start by thinking about the 15. And I ask myself, what numbers can multiply to 15? 1 and 15, 2, no, 3 and 5. That's it. And now I think, with some subtracting or adding, which one could equal 2? It would be 3 and 5. But I got to think about which one should be negative. I'm going to try it on my calculator. 3 plus 5, that doesn't work. What about 3 plus negative 5? No. What about negative 3 plus 5? Hey, that works. So I need to make my 3 negative. So in final factored form, I separate the x squared into x and x, and then I would have a negative 3 and a positive 5. Beautiful. All right, let's look at this next one. First things first, you're always going to think, is there a number and a letter that you can divide out? Well, my smallest number here is 3, And I do actually see that 3 can divide by all of these terms. There's not an x in every term, so I can't do anything with the x. So I'll have 3. 3 divided by 3 is 1, x squared. 9 divided by 3 is 3, x. And negative 30 divided by 3 is negative 10. Beautiful. Now, I see that this is a trinomial, 3 terms, so I could do the add multiply method. I'm going to find what adds to 3, but those same 2 numbers, same signs and everything, also got to multiply to negative 10. So let's think about what multiplies to 10. We could have 1 and 10, but that will never add or subtract to equal 3. Or I could have 2 and 5. And guess what? 2 and 5 could equal 3. Let's see how. 2 plus 5, no good. Let's try negative 2 plus 5. Hey, that works. Negative 2 and 5. So how you write your final answer is, don't forget that you had this original 3 on the outside. But now to separate this trinomial, you're going to write 2 binomials. To separate the x squared, you make it x and x. And then we have a minus 2 and a positive 5. Does not matter the order that you write those 2 in. And that is your final answer. Alrighty. Now let's look at this next method of factoring that we learned. We learned the method of difference of perfect squares. If you remember your perfect squares numbers, these were like 1, 4, 9, 4 times 4 is 16, 5 times 5 is 25, then 36, 49, 64, 81, 100. I want you guys to have this list of perfect squares memorized. Because then as soon as you see a binomial with subtraction, binomial means 2 terms with subtraction, and both of the numbers are perfect squares, you know this is the method that you are using. So let's first see if there's anything we could divide out. Well, this has a 1, so dividing by 1 wouldn't help us. And they both don't have an x, so that's not going to help. But these are both perfect square numbers, 1 and 36, and it is a difference. So make 2 sets of parentheses. The square root of x squared. Well, the square root of 1 is just 1. And the square root of x squared, you divide the exponent by 2. 2 divided by 2 is just 1, so we would just have 1x and 1x. Then the square root of 36 is 6 and 6. And now the only way to get to a negative 6 is by having a negative and having a positive. So that would be our final answer. And let's look at the next one. First thing, always ask yourself, can I divide by a number? Well, the smallest number I have is 4. And I can't divide by 4, 3, 2. The only one that would work is 1. But 1's not going to change anything. And they both don't have an x. All right. So now let's take the square root of both of these. The square root of 4 is 2 and 2. And to separate an x squared, you just separate it into x and x. And then the square root of 25 is 5 and 5. And the only way to get a negative 25 is by having a negative 5 and a positive 5. Perfect. Alrighty. So that is factoring the difference of perfect squares. Alright, so now that we went over the 3 different methods that we learned how to factor out a GCF, how to factor trinomials where you do the adding and multiplying, and then we learned how to factor difference of perfect squares. Now we are going to do what's called factoring completely. This is just where you need to use all the methods and not be told which one to use. So first things first is to always try to take a GCF. Always try to see if you can divide by the lowest number or a different number. See if you could take out a variable. This is only possible sometimes. Then if it's a trinomial, do the adding and multiplying to factor that. Or if it's only a binomial, then you would factor the difference of perfect squares. And when you're finished, just make sure what you are left with cannot be simplified or factored out more. All right, so let's look at this I do question. I'm first going to ask myself, is there a smallest number? Yes, 3. Can I divide each thing by 3? Well, does 84 divide by 3? It does. So I can divide all of these by 3. They don't have an x, so I have to just forget about that for now. So 3 divided by 3 is 1. Bring down the x squared. 9 divided by 3 is 3. bring down the x, and negative 84 divided by 3 is negative 28. Perfect. Now we are left with a trinomial, which means we are going to see, can we find what adds to 3 and multiplies to negative 28? Sometimes it might not work, but that's not very rare. Let's see. To multiply to 28, we would have 1 and 28, 2 and 14. Let's see, does 28 divide by 3? No. Does 28 divide by 4? 4 and 7. All right. I need to think of which set of these numbers can somehow get me 3. It would be 4 and 7. But how would I get 3? 4 plus 7, no good. 4 plus 7, no good. Negative 4 plus 7? Hey, that gets me 3. So it would be negative 4 and positive 7. And this is our final answer. That's factored completely. You had to do 2 different steps to completely get it to simplest form. Let's look at the next one. So in the next one, I'm going to see, can I factor out that 5, the smallest number? I actually can. I cannot factor out an a since both of them don't have an a. 5 divided by 5, just 1, leaving us with a squared. And then negative 45 divided by 5 leaves us with negative 9. This is now a binomial, so we see, can we take the square root of both these numbers? We could take the square root of a squared, and we can take the square root of 9. Good. So we'll have 5, 2 sets of parentheses. To separate a squared, we get a and a. To separate 9, we get 3 and 3. And the only way to get a negative 9 is to have a negative and a positive. And that is our final answer. Alrighty. Let's look at this next problems. This is a we do, so I really want you to pause it, try it, then see if I got it. All right. My smallest number here is 2. Since all of these are even numbers, I know I can divide by 2. And then, actually, all of them have an x, and the smallest x is x1, so I could actually take out that x1. So my GCF is 2x, and now 2 divided by 2 is 1, x to the third divided by x1, subtract the exponents, we get x squared. Negative 24 divided by 2 is negative 12. x2 divided by x1 just leaves me with x. And then 64 divided by 2 leaves me with positive 32, and those x's would cancel out. Because I am left with a trinomial that has 3 things, I'm going to see, can I find out what adds to negative 12 and multiplies to 32? Well, let's start with 32. What numbers multiply to 32? 1 and 32, which would never get us 12. 2 and 16, that wouldn't get us 12. Does 32 divide by 3? No. 32 divided by 4? Oh, 4 and 8. That could get me 12, but I need to get negative 12. And the only way I'm going to get negative 12 is if I make the 4 negative and I make the 8 negative. Let's double check. Negative 4 plus negative 8. Good, that gets us negative 12. And negative 4 times negative 8, that gets us positive 32. Beautiful, this is our final answer. Let's look at the next one. See if we can divide out a number. We can divide out a 3, so that's great. So then I'll have 3 m squared. Negative 27 divided by 3 is negative 9. And now this is a binomial with 2 perfect squares. To take the square root of m squared, you do the variable, the exponent, which is 2 divided by 2, just leaving us with m1. And then the square root of 9 is 3. Only way to get a negative 9 is with a negative and a positive 3. And if you went through and multiplied, you would end up with the original answer. All right. Now I really, really need you to pause this and try this one on your own. The only way you're going to see if you understand it is by trying on your own. All right. There's no number I could take out here, but they all 3 do have an x, so I can divide by x. The x1. So x3, take away x1, would leave me with x squared. Then I have to bring down my 7. X squared divided by x1 just leaves me with x. And then 10, and the x's cancel off. Good. This is a trinomial. So I'm going to think what adds to 7 and multiplies to 10. We're trying to add to 7 and multiply to 10. Well, the only numbers that multiply to 10 are 10 and 1 or 2 and 5. And luckily, 2 and 5 would work. A positive 2 and a positive 5. Double check it in your calculator. Is 2 plus 5 7? Yes. Is 2 times 5 10? Yes. Perfect. All right, let's look at the next one. All right, I see my smallest number is 12, but I cannot do 27 divided by 12. So let's think of the numbers that multiply to 12. 1 and 12, 2 and 6. 27 doesn't divide by 6, 3 and 4. 27 doesn't divide by 4, but 3 does work. They both don't have a b, so I have to forget about the b for now. 12 divided by 3 is 4. Bring down the b squared. Then negative 27 divided by 3 is 9. And luckily, by doing this, we left ourselves with 2 perfect squares, so we can do the difference of perfect squares. The square root of 4 is 2, and separate the b squared to b and b. And the square root of 9 is 3 and 3. And that is our final answer. Inside the parentheses, you see a 2 and 3. There's no way to simplify a 2 and 3 by dividing by the same number, so that is our final answer. Alrighty. I just want to do a rapid Regents review. When this, right here, let's start with that, 2x minus 3 squared, that means we need to write that twice. Let's multiply that. 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. Negative 3 times 2x is negative 6x. And negative 3 times negative 3 is positive 9. Let's put together the like terms. We'd be left with 4x squared. Then negative 6 minus 6 is negative 12x plus 9. And it says, is subtracted from 5x. Meaning you need to put this and then subtract your 5x squared. Because subtracted from, you do it in the opposite order. So we would have 5x squared. I need to distribute this negative. With negative 4x squared, distribute this negative. That would give me positive 12x. Distribute this negative. That would give me negative 9. 5x squared minus 4x squared is x squared. Bring down the plus 12x. Bring down the minus 9. That gives me an answer of 3. Alrighty. And now we are left with the exit ticket, and there will be homework, so make sure you do all of that. Remember, factoring completely, we take out the GCF if possible. If there's a number we can divide, then we factor the trinomial. If we see 3 terms, we do the adding and multiplying technique. And then we factor a difference of perfect squares as many times as possible. All done.